Now see this question. This question is given in GATE 2014 in the subject signals and systems. Is given in GATE 2014 in the subject signals and systems. I'll read the question. The sequence x of n equal to 0.5 power n u of n, where u of n is the unit step sequence and is convolved with itself to obtain y of n. They are asking sigma n equal to minus infinity to infinity, y of n is dash. From the given, x of n is convolved with itself to form y of n. So it will become y of n is equal to x of n convolved with x of n. Okay. From this, apply z transform. Apply z transform. After that, we get y of n becomes y of z. This will becomes x of z into x of z. That is equal to x of z whole square. So y of z equal to x of z whole square. This is equation 1. Take it as equation 1. Then from given x of n value 0.5 power n u of n. While solving these kind of questions, you should remember two important formulae. I'll write down formula here. If it is in the form of alpha n u of n, if you apply z transform, you get 1 by 1 minus alpha z inverse. Okay. So this is in the formula of alpha power n u of n. Apply z transform. Apply z transform to get x of z as 1 by 1 minus 0.5 z inverse. Okay. Then we will get y of z from equation 1. Y of z equal to x of z whole square, that is 1 minus 0.5 z inverse whole square. This is equation 2. So up to now we have got y of z as 1 by 1 minus 0.5 z inverse whole square. Now we will write let x1 of n is equal to, let x1 of n into x1 of n is equal to n into 0.5 whole power n u of n. Whenever you encounter n into alpha power n u of n, you apply z transform, you will get alpha z inverse by 1 minus alpha z inverse whole square. Okay, this is same as the above, n into alpha power n u of n, you apply z transform. For this also apply z transform. We get 0.5 z inverse by 1 minus 0.5 z inverse whole square. But to finding out y of n, you should not having any term of z. Here we are having z inverse in numerator. For eliminating this, apply time shifting property. Apply time shifting property. Means in the place of n, you put n plus 1. Okay, in place of n, you put n plus 1. So n plus 1, x1 of n plus 1 is equal to n plus 1 0.5 power n plus 1 u of n plus 1. So apply same z transform to this also. Apply z transform, you will get 0.5 z inverse into z by 1 minus 0.5 into z inverse whole square. Okay, now z inverse cancel, that is equal to 0.5 by 1 minus 0.5 z inverse whole square. If you observe this and this clearly, only in the numerator 0.5 is multiplying this y of z. So it implies 0.5 sent to this side. So we will get y of n as this 0.5 goes to denominator, n plus 1 by 0.5, okay, into 0.5 power n plus 1 into u of n plus 1. So finally we get y of n. How I have written this? Because here z transform of this transfer function and this transfer function both are same except this 0.5 in the numerator. Then we can say that input functions will be also same since z transforms are same. So by dividing 0.5 here we got y of n here. Now we have to find sigma n equal to minus infinity to infinity y of n. Write the same, n plus 1 into 0.5 whole power n plus 1 into u of n plus 1 divided by 0.5. Take 0.5 to outside, n equal to minus 1 to infinity n plus 1 0.5 power n plus 1. Let m equal to n plus 1. Now if n equal to minus 1, m is 0. n equal to infinity, if this side is infinity, this side also infinity, m is also infinity. Substitute these values here, 1 by 0.5 sigma m equal to 0 to infinity. This is m and 0.5 power m. Here just I am substituting m in place of n plus 1. If you expand this, it will become 0.5 is 0 into something is 0 plus 1 into 0.5. This is 0.5 plus 2 into 0.5 whole square and so on. Okay, this is in the form of x plus 1, x plus 2x square plus 3x cube and so on. This is like binomial expansion from binomial expansion. Here x is less than 1, 0.5 less than 1, true, so it is 1 minus x whole power n, that is equal to 1 minus 0.5 whole power 0.5. I think this is equal to 1 by 2 whole power minus 2, that is equal to 4. Since minus 2 we can write it as 2 whole power 2, that is 4. So the answer will be 4. Now how we have got this is, so x is convoluting itself, so we have find out y of n, then apply z transform, we have got y of z equal to x of z whole square. By applying z transform to the given x of n, we have got x of z, and by taking simple assumption of n and time shifting property, we have got value of y of n as this n plus 1 into 0.5 power n plus 1 u of n by 0.5. Then simply substituting into the limits minus infinity to infinity summation, we have got this value, and this is as same as binomial expansion. We have got x less than 1, so 1 minus x whole power n, it is 1 by 2 whole power minus 2, that is 4. The answer will be 4.